Hey, math class. Today we're going to talk about the order of operations. So we've kind of talked about all of this whole number stuff, add, subtract, multiply, and divide. But the other thing that we want to talk about with that is the order that you do things in. Because even though we've kind of worked through everything, add, subtract, multiply, divide in this sort of linear progression, that's not actually, when you have a problem that has all of the whole numbers sort of smushed into one problem, you don't solve them in that linear way. You have to solve them by this order of operations. And you may have heard this referred to as Pemdas. You see it right there. Or you may have heard this mnemonic kind of memory device, please excuse my dear Aunt Sally. And that's a good thing. Either one of those two things, PEMDAS or the please excuse my dear Aunt Sally, is a good way to sort of keep in your mind the way that everything, the order that you go through to solve a problem, and which one goes first and which one goes last. So the P stands for parentheses. So anytime you have the parentheses, that goes first. Excuse, the E stands for exponents. We'll talk about those in a second. The M stands for multiply, D for divide, A for add, S for subtract. And so again, like the first thing that you do all the way down to the last thing that you do. So let's put this into practice and look at a problem. Okay, so here is my problem. 30 divided by 5 plus 25 times 3. So if I look back at my thing here, I don't have any parentheses, no parentheses, I don't have any exponents, but multiply and divide, that's the first thing that I'm going to do, because I have multiply here, I have divide here, and I'm just going to work from left to right. So 30 divided by 5 will give me 6. And 25 times 3, oh gosh, 25, I don't really know my 25s, but if you think about this, you really kind of do know your 25s if you know money. If I have 25 cents, which is a quarter, right, and I have 3 quarters, how much do I have? Oh, that's easy, I have 75 cents. So if you think about it as money, you can tell really easily that 25 times 3 is 75. And then if you see here, this is the only thing that didn't get used in sort of that first pass through this problem. So I'm just going to bring him straight down, okay? And so then, if I look back here, so I've done multiply and divide. All I have left to do is add and subtract. Those are my last 2 operations in the order of operations. And so that's what I can do here. 6 plus 75 equals 81. So that's my answer. So it's going to feel like you should start over here and work left to right and do this adding, kind of there in the middle. But if you do that, you're going to get the wrong answer because it really does have to be done using this order of operations. Let's look at another example just to sort of hopefully make it clearer. Okay, so this one, so it's 3 times the stuff in the parentheses, 8 minus 3, minus 6 divided by 2. So I'm going to come back to my order of operations here. And so my first thing to do here is parentheses. So I simply do anything that's involved in these parentheses, I do that first. So I start with 8 minus 3, which is 5, okay? And I'm going to leave the parentheses in here just so that I can kind of remember that that's where it came from. And then everything else I'm just going to bring straight down because I didn't deal with it at all. And if you remember from, the previous video, anytime that you have stuff in parentheses, that always means multiply. So this would be 3 times 5, which is a good thing to remember because, look, multiply and divide, those are the next things that I do on my list. Okay, so 3 times 5 is 15. And then if I come over here, again, I'm working left to right. 6 divided by 2, that's 3. And then again, that's the only guy that I haven't used on here. So I'm just going to bring him straight down. And now I have 15 minus 3. Add and subtract. If you look here, add and subtract. Those are my last two things to do. So 15 minus 3 is 12. So my correct answer on this one would be 12. Let's look at another example. But first, one thing I want to say. You might be thinking like, gosh, Heidi, you're putting this up and taking it down too fast. And the reason for that is we're referring to it. But also, too, I'm going to give you a copy of this in class tomorrow. So, don't worry about like pausing the video and trying to write it all down. Hopefully you haven't done it yet. But I'll be giving you like the exact same thing as this to keep in your notebook to refer back to. So let's look at another problem here. Look at this one. Let me get it squared on the screen here. So 5 to the second plus this whole thing, 4 times 5 minus 2 divided by 9. So this is incorporating an exponent, and we haven't really talked about those yet. If you look, it's the second thing. It's the the E on our order of operations. We have to solve exponents as the second thing after anything with a parenthesis. So let's go ahead and solve the stuff in the parentheses first. And the funny thing, if you look at this, we're going to have to use the order of operations within the parentheses. How crazy is that? But that's just sort of how this goes and why it's important to know the order of operation or order of things, the order that we do things in. So if you remember, we have multiply and subtract. So multiply comes, let me get it on the screen here. Multiply comes before subtract. Okay, so I have to do 20 minus 2, and then I do 20 minus 2, which is 18. So that 18 is this whole parentheses. That's my answer for the whole parentheses. And then I'm going to bring everything else down, including that exponent thing. And so since we've got the parentheses done, that exponent, that's the next one that I have to deal with. And so let's sort of talk a little bit about what an exponent is. Because, it sounds a little scary. And with a lot of things in math, they give it a big, scary name, and it really is something very, very simple. So if you look at this, an exponent always has two parts. It has the base, which we have here in this sort of purpley color, and it has the actual exponent. And that can be seen there in the green. And what it really means is that I am going to write the number 4 2 times, because the exponent says 2, so I write the number 4 2 times, and I'm going to multiply them. That's it. That's all it means. And this is pretty easy to solve. 4 times 4, 16. Ta-da! So even though it sounds sort of, weird and algebra-y, it definitely sounds like an algebra kind of word, it really is just a whole numbers thing. Let's look at another example. If I had 2 to the third, or we could say 2 cubed. Really, all that means is that I write the number 2 3 times, and then I multiply them. That's it. And again, we can totally solve this because we know how to multiply. 2 times 2 is 4, times 2, 8. Okay, so if we come back to our problem and sort of keep that exponent thing in mind, here's our problem. This 5 squared, all that means is I'm going to write 5 twice and multiply it. And we know what that is. 5 times 5, 25, right? So there we've got that all finished. And then I'm going to bring everything else down. Plus 18 divided by 9. What's the next thing that I have to do on my order of operations here? So I've got through the parentheses, I've got through the exponents. Multiply and divide. And I only have one of those left, right? 18 divided by 9 is 2. And then I bring everything else down. And then my last things to do are add and subtract. Very, very last thing. So all I've got to do is add 25 plus 2, 27. So even though I started out with this kind of big, scary looking mess of numbers up here, my answer comes out to be this very nice 27 whole number. We got there pretty easily, and we'll be practicing this order of operations and kind of dealing with these exponent things more in class tomorrow.